go through the do now and everything else for class today. So for the do now, for these questions, 1, 2, 3, and 4, they do not go together. They're all separate questions. So just keep that in mind while we're going through the do now. So for number 1, if the rate law for this reaction, 2A plus 3B yields products, is first order in A and second order in B, then what is the rate law? So remember on Friday we talked about experimentally determining the rate law if they don't give us the orders. So in this case, they give us the orders. So they tell us that A is first order, B is second order, and they want us to write the rate law. So keep in mind that rate law is always rate equals K times concentration of reactants. So if we have rate equals K times the concentration of A to the first power times the concentration of B to the second power, because your exponents are your orders. Now, if you put the 1 after A, that's fine. But your rate law for number 1 is rate equals K times the concentration of A times the concentration of B squared. Your exponents are your orders. For number 2, a reaction was found to be third order in A. So A is a third order reactant. Increasing the concentration of A by a factor of 3 will cause the rate to do what? So remember, if we think back to the orders, if it's 0 order, concentration has no effect on rate. If it's first order, like in number 1, A is first order. Whatever we do to the concentration, we do the same thing to the rate. For second order, whatever we do to the concentration, we do that squared to the rate. And then if it's third order, whatever we do to the concentration, we would do that cubed to the rate. So in the case of number 2, if we're increasing the concentration of A by a factor of 3, that means think about putting a 3 inside the brackets and there being a cubed on the outside. 3 cubed, what is that? 3 times 3 is 27, 27, no, that's 9. 9 times 3 is 27. So for number 2, since A is third order, since this reactant is third order, there's going to be a 3 as the exponent. So increasing A 3 times will increase the rate 3 cubed times, which is 27 times. So number 2 is 27 times. Number 3, a reaction is found to be 0 order in A. Increasing the concentration of A by a factor of 3 will cause the rate to do what? So remember, 0 order means that the exponent is a 0. When the exponent is a 0, that is the number 1. So it's not in the rate law at all. So 0 order reactants, you can do whatever you want to the concentration, the rate's not going to change. So for number 3, changing the concentration will not affect the rate. So since A is 0 order, it's not going to be in the rate law. So changing the concentration won't affect the rate. And then finally, number 4, the kinetics of the reaction below was studied. It was determined that the reaction rate did not change when the concentration of B was tripled. The reaction is what order in B? So if the rate did not change when B was tripled, that means the rate does not depend on concentration of B. So it's 0 order. All right, so the red boxes have our answers. This is a lot about thinking about the orders, 0 order, first order, second order. Sometimes we could see third order, but thinking about what happens with concentration, how that affects the rate. Okay, so that's the do now for today. As we continue looking through, we look ahead at this week. So today is going to be the kinetics quiz. For first period, it ended up being that the quiz was during the second period of class, because if you notice in the lesson plans, we're actually going to review before the quiz. So we're going to go through a review. First period said it was very helpful for the quiz. So we'll go through, if you notice here underneath the kinetics quiz, right? I didn't want to tell you until today because I wanted to make sure you still reviewed for the quiz, but it will be open note. So you'll be able to use your notes. That's why I said you want your notes out for today. So that way you're using them as we go through the review. And that way you know where everything is in your notes. Now here's the thing, is the quiz is timed. The quiz will automatically close when the time is up. So you cannot rely completely on your notes because you're going to run out of time. But you will have your notes in case you need them as a resource. After the quiz, we will start a simulation. So the simulation is like a virtual lab. The handout and assignment is in Google Classroom. I posted it yesterday. Everything is spelled out for you. I'll talk more about it on the next slide. Tomorrow, we'll be doing an exam prep number 1. I'll talk more about this tomorrow. Essentially, it's a practice exam that was written for our classes. So there's a group of AP teachers that these exams were written for. Again, I'm going to talk way more about this tomorrow. There's no need to stress about it. It's 18 multiple choice, 3 free response. It's more of a check to see where we are. And you'll only be graded on the reflection part of it, not how well you do on the questions themselves. And then Wednesday is a work day. So Wednesday, you'll have time to work on the Beers Law simulation if you need to continue working on the reflection from tomorrow. But Wednesday will just be a work day. We'll have a do now, and then you'll have time to work. Mastering, remember, you can go through number 19, but I want you to do nothing AP Chem related over break. So I'm not giving you homework over break. Yeah, mastering is open, but don't work on it, right? Don't work on anything AP Chem related. I want you to take a break, right? Take a break from school. Your brains need a break. You probably just need a break, like mentally. So I'm not giving you any work over break at all. So before we review, just a quick thing on this simulation. So Beers Law is a topic that's covered by College Board on the AP exam. We usually do labs with Beers Law, and hopefully spring semester we're going to be able to do more labs with Beers Law so you can actually do it in the lab and not necessarily virtually. But to be able to do one of the labs, we're going to do a simulation. So if you've heard of PhET, that's an online simulation. It lets you play around with things like you're doing lab. We're going to be using spectroscopy. So that's like flame test. That's a type of spectroscopy. But you're looking at how light affects colored solutions. So we're going to be changing concentration and measuring absorbance. So on Google Classroom, again, this is completely laid out for you. You are not doing this in your lab notebook. So that's why I'm not calling it a lab. I'm just calling it a simulation or an assignment. You're just going to answer everything directly in the Google Doc that's linked in Classroom. So it is set up like a lab. That way it's similar to what you're used to. So there's background. Make sure you read that background information. There are pre-lab questions, and then you'll go through everything. And then there's critical thinking questions at the end. So you'll type everything directly into the Google Doc. That's what you'll turn back into me. And it's due Wednesday at 2:30. So if you don't get it done today, that's okay. Wednesday is a work day. You can work on it during all of class Wednesday. But that's just to go through the simulation. So this is what you can open up. You can start on it after you finish the quiz. So before we take the quiz, I want to make sure that we can review things that we talked about Friday. And so what we're going to do is we're going to use Pear Deck again, and I'll open it up. I'll share the link with you. But in this review, we're going to focus really specifically on what we did Friday. So we're going to use the method of initial rates to look at rate laws, rate constant, things like that. Rate of disappearance and appearance is not on this review, but that's what we did Thursday. So remember that when you see on the quiz that it says rate of appearance or rate of disappearance, use the balanced equation, use the coefficients. So rate of appearance, rate of disappearance was like examples 2, 3, and 4 that we looked at on Thursday. And so just keep in mind that's not on this review, but you will still see it on the quiz. So as we go through this review, use your notes, use a calculator, use, if you want, like a blank piece of paper, so that way you can work through everything you can. But that way you can kind of treat it as if it were like part of the quiz. So I'm going to go ahead and I'm going to pull up the information for the review. So we've done these Pear Decks before, so it's going to pop up with the website. I'll put this link into the chat, so you can just click on the link as well to join. Right, so if you just click on that link that I put in the chat, that will have you join this session as well. Or you can go to joinpd.com and you can type in the code XSTOXT, and that'll let you join. So again, this is so that we can review everything for the quiz. If you have any questions as we're going through, feel free to type them in the chat. If you'd rather send it via Remind, you can. I have Remind open on my other computer and it'll pop up on my watch as well. Okay, so it looks like we have some people. If you still need to join, looks like we have 18 that have joined right now. So again, you can either go to the website that's on the screen, or you can click on the link that's in the chat. As we go through, just like when we played Kahoot, if I notice that a lot of people are missing a question, I'm going to go over it. If everyone is getting it, I'll just do a very short overview. So I'll go ahead and start. If for some reason it's taking a little bit, you can always click on the link that's in the chat. So for the first part of this, and there's no question on this slide, but to review what affects rate. So remember that kinetics is how fast reactions occur. So the speed at which reactants are converted to products. We talked on Thursday how we can change concentration, we can add a catalyst, we can change temperature, we can change surface area. Anything that affects collisions between the reactant particles will affect the rate of reaction. Then we looked at rate laws, and we talked about how rate laws allow us to connect rate to concentration. And so that's what we're going to focus on in this review. But again, remember that rate of appearance and disappearance is not on this review, but you do need to know that. When you see the term appearance, disappearance, remember that you need to base it on the coefficients in the balanced equation. So for this first slide, we have this table, it has 3 experiments, and it says order the experiments from slowest to fastest rate, and you're going to drag and drop the numbers. You have 1, 2, and 3. 1 is the slowest, 3 is the fastest. So I want you to focus on the column that says initial rate of reaction, because rate, that's slow to fast. So look at the value of the initial rate. I want you to put them in order. Which one is the slowest? Which one is the fastest? So put them in order 1, 2, and 3, 1 being the slowest, 3 being the fastest. Again, just look right at that column, the initial rate of reaction. The lower your value, the slower the reaction. The higher your value, the faster your reaction. Because the higher your value of rate, the more molar per second is reacting. Good, so I see a lot of people dragging and dropping in different places, which is fine. All right, so here's what I want to look at. Right, let's focus on the initial rate of reaction. It looks like a lot of the 1s, 2s, and 3s are overlapping. So experiment 1, that's the slowest rate because the rate is 0.0575. That's the slowest rate. 0.230, that's the fastest rate because 0.23, that's the highest number. Good, and I see people even moving it around to make sure that they have the right answer. So 0.230 molar per second. That means you have a lot more molarity per second reacting versus 0.0575. Good, so we can see the answers here. 0.0575 is the slowest, 0.230 is the fastest. So all that's doing is having us look at the value of the rate, keeping in mind that the higher the value, the faster the rate. So now I just want you to talk about the order that you just put in. Why do the 3 experiments have different rates? So what is in this table? What is in this table that is causing it to have different rates of reaction? So based on those factors that we talked about on Thursday, what is changing that's allowing the rate of reaction to change? All right, and we're not getting into the rate laws and stuff yet. I just want to know, why is the rate changing? Why does the rate change looking at this table? Yeah, good. And I see people are still typing, but everybody seems to have, right, the right idea. And if you notice here, notice how right above the table it says initial rates for several experiments at 25 degrees Celsius. So it says that the temperature is the same, right? All of these are at 25 degrees Celsius. It doesn't say anything about a catalyst, right? So if we take a look at some of these, right, they have different concentrations of reactants. Concentration of each reactant changes. So the concentration is different. Different concentrations will result in different rates. Yeah, so, and some people even noticed why we have the higher rate in experiment 2. Right? Some people said in experiment 2, the concentrations are higher, so the rate is higher, and that's true as well. So this is just looking at the idea that more concentration will result in a faster rate, or different concentrations will result in different rates. So looking at rate laws, so just to review rate laws, remember that any rate law, is rate equals K times the concentration of reactants. And this N, that's the exponent, that's the order. Could be 0, first, second order. We might see some that say third order. Typically, we see 0, first, and second order. Remember, K is a rate constant. Rate constant only changes when temperature changes or when we have a catalyst. As long as we're at the same temperature, K will be the same. So here's what I want you to look at with this question. So this table gives us reactions and it gives us a rate law. So it already writes the rate law for us. So based on the information presented in this table, is the order of each reactant always equal to the coefficients in the balanced equation? So take a look at each of the rate laws. Is the rate law, is the order of each reactant always equal to the coefficients? Good, I see a lot of people answering this question. So again, just do a double check. And if you look at even the first reaction, N2O5 is first order in the rate law. Does that match the coefficient in the reaction? All right, so a majority said no. Right, so no is the correct answer. Because again, if you take a look at the first reaction, there's a 2 in front of N2O5, but in the rate law, it's first order. It does not always match. That's why we say that it has to be experimentally determined. So they experimentally determined these rate laws for us. It does not always match the coefficient. That's why we cannot use the coefficients when we're writing the rate law. So in this goes through reaction orders. So we use what's called the method of initial rates. That's where we have the table and we look at how concentration changes. So this table up here shows us if we have 0, first, and second order and how concentration will affect the rate. Now, down here at the bottom is the actual question, right? Consider a reaction that is known to be first order with respect to A. If the concentration of A is tripled, how will the rate be affected? So if it's first order with respect to A and we triple the concentration of A, what's going to happen to the rate? You have a multiple choice question for this. So again, it's first order. And if you look at this table up here, it tells you what happens if it's first order, right? If A is doubled, the rate doubles. Well, we're not doubling in this case. If we're tripling the concentration, what would happen to the rate? So we have about 16 responses out of 20. And let's look and see what people are choosing for this. All right, so majority is choosing A. So again, if it's first order, whatever you do to concentration, you also do to rate. So if you triple the concentration, you're going to triple the rate. All right, so A is the correct answer here, right? The rate would be 3 times the original rate. Now, if it were second order, that's when we would be looking at the 9 times. But since it's first order, whatever we do to concentration, we do to the rate. So now this next question, consider a reaction that is known to be second order with respect to B. So if the concentration of B is tripled and it's second order, how will the rate be affected? Good. And I guess I did just talk about this. All right, so it's second order. So think about whatever you do to concentration, you're doing that squared to the rate. Good. Everybody's picking the same answer for this one. All right, the rate would be 9 times the original rate. Because think about if you plug a 3 into the rate law and there's a 2 up as the exponent, 3 squared is 9. So it would be 9 times the original rate. So now for this, this is having you drag numbers. You will not use all of the numbers. Right? You can drag 0, 1, 2, and 3. You may not use all of them. But I want you to drag and drop. What is the order of A? What is the order with respect to B? And what is the overall order using this rate law given? So one, and I'm trying to show you different ways that AP would word this. If it says, what is the reaction order with respect to A? It wants A's order. With respect to B means it wants B's order. Right? And again, you might not use all the numbers. Good. So a lot of people are dragging and dropping. I see the overlap of all of the numbers, which is good because it looks like all the same numbers are overlapping. So remember, you use the rate law. Well, you can use the rate law to determine order. So rate equals K times the concentration of A to the first times the concentration of B squared. So if we take a look, right, notice everybody said A is first order, B is second order, and overall is third order. So that's because you look at these exponents. A has an exponent of 1, B has an exponent of 2, and then you add them up for overall, which is third order overall. Okay, good job. So now we're going to get into this method of initial rates. This is where Friday we looked at how concentration changes and how the rate changes. So if we go back to this table that we looked at before, I want to know what is the order with respect to ClO2. So I want you to look at changing the concentration of ClO2 when OH minus stays constant and see how it affects the rate. So use your calculator if you need to. What is the order with respect to ClO2? Is it 0, first, or second order? Again, use your calculator. If you're looking for the order with respect to ClO2, you're looking at how does ClO2 change while OH minus stays constant, and what does that change do to the rate? Okay, so we have about 12 responses so far. If you're stuck, here's a kind of a reminder. See how ClO2 changes from experiment 1 to experiment 2. So 0.05 to 0.1, what is happening there? And what is happening to the rate from experiment 1 to experiment 2? The reason you're using 1 to 2 is because you only want one reactant to change at a time. So we actually have a kind of a split here with this question as I look at the results. So here's what I want us to look at from 0.05 to 0.1, right? Use your calculator. So if I do 0.1 divided by 0.05, that's 2. So from 0.05 to 1, that's doubling. So if I look at the rate of reaction, I'm going to do 0.23 divided by 0.0575. That's 4. So when I double the concentration of ClO2, the rate increases 4 times. So if I double and it quadruples, that's 2 squared. That results in a second order reactant. So ClO2 is a second order reactant, right? Because when I go from 0.05 to 0.1, that's times 2. 0.0575 to 0.23, that's times 4. So whatever I'm doing to the concentration, I'm doing that squared to the rate. So ClO2 is second order. Now I want to know what is the reaction order with respect to OH minus. So look at where OH minus changes, but ClO2 stays constant. So I would recommend looking from experiment 3 to experiment 2. It's going to be easier to work with that way. So from experiment 3 to experiment 2, OH minus doubles. Look at what happens to the rate and what that would mean about the order. Yeah, good. So we have everyone choosing first order, which is correct. Again, the reason that it's first order is because as I double the concentration of OH minus, I double the rate. So whatever I'm doing to the concentration, I'm doing the exact same thing to the rate. So based on your answers to the previous 2 questions, what is the experimental rate law? So just a reminder, we said ClO2 is second order, OH minus is first order. So what is the experimental rate law? This is using the method of initial rates, meaning that we have to determine the order using the data, and then we can write the rate law. So again, a reminder, we said that ClO2 is second order, OH minus is first order. So what rate law would describe that? ClO2 is second order, OH minus is first order. Remember that rate laws are rate equals K times the concentration of reactants raised to their orders. So B is the best answer for this. ClO2 is second order, OH minus is first order. So rate equals K, yep, good. Because again, your exponents are your orders. All right, so for this, remember that a rate constant is constant as long as we're at the same temperature. So all of these experiments are at 25 degrees Celsius. So I want you to calculate the rate constant. So calculate rate constant and include units. So remember, when you're calculating rate constant, you need to use the rate law that we just wrote. Rate equals K times the concentration of ClO2 squared times the concentration of OH minus. Pick one of the experiments, plug into the rate law, and solve for K. So I'll give you a second. I want the value and the units. I want the value and the units for K. Remember, you're using the rate law. You need to make sure that you're using that rate law that we just wrote. Rate equals K times the concentration of ClO2 squared times the concentration of OH minus. right? So as you are working through everything, remember that ClO2 is squared. So when you're plugging into the rate law, you should have rate equals K times ClO2 squared times OH minus. Pick one of the experiments. I actually picked experiment 3. So the way that I would plug it in is I would do 0.115 molar per second equals K times 0.1 molar squared for ClO2 times 0.05 molar. So if I did 0.115, and again, you could do it for any of these. You're going to get the same thing. A lot of people probably did experiment 1. Right, you should get, and most people, it looks like, got 230 as the value. So the value is 230. Then it comes to looking at units. So remember on page 7 of the notes, we filled in the summary table for the overall order and the units for the rate constant. So the overall order of this rate law is third order, 2 plus 1. Or you can plug in the values. When you plug in the values, you actually get m to the minus 2, s to the minus 1. Right? Or 1 over m squared times s. Right? So m to the minus 2, s to the minus 1, or 1 over m squared times s. Either one of those works. But remember, for third order overall, your units are m to the minus 2, s to the minus 1. Right? Good. So just remember, you can pick any of these experiments and you can plug in the value to solve for the rate law. So again, here's the table. The units for the rate constant are dependent on what the overall reaction order is. So this was third order overall because it was second order for ClO2 and first order for OH minus. So it's third order overall. So your units are m to the minus 2, s to the minus 1. So whether you work it out every time or you just memorize this table, that's up to you, but you do need to know units for rate constant. So now we're going to put everything together. So for number 1, so you're going to answer all of this in the same text box. Don't worry about formatting. I'll be able to tell what you mean. But for number 1, I want you to write the experimental rate law. So you need to use method of initial rates. That means you use this table to figure out what the order of each reactant is. Then you'll do rate equals K times the concentration of reactants. Then based on your rate law, you're going to calculate the rate constant. Now, remember that you're looking at changing one reactant at a time. So you need to first look at where does H2 change, but NO stays constant. What happens to the rate? And then where does NO change, but H2 stays constant, and how does that affect the rate? Right? Then you're going to calculate the rate constant. Remember, the rate law is not based on the balanced equation. It's based on the data. So again, in order to write your rate law, you need to look at how everything is changing. You want to look at one reactant at a time. And so again, you want to check your rate law. And so I was leaving some feedback on some people's, as they're typing, I was trying to leave some feedback while watching everybody write. And I tried to leave some feedback on rate laws. As H2 changes, so if you look at H2 changing, NO has to stay constant. So we're going to look from trial 1 to 3. As H2 doubles from 1 to 3, with NO staying constant, as H2 doubles, the rate doubles. So whatever you're doing to H2, you're doing the same thing to rate. That's first order. We look at NO changing while H2 stays constant from 1 to 2. As NO doubles, the rate quadruples. So as NO is multiplied by 2, the rate is multiplied by 4. That's second order. So H2 is first order. NO is second order. And then once you have that rate law, pick one of the trials, plug in that information to the rate law, and solve for K. So if I'm going to pick trial 4, doesn't matter which one you pick. When I used trial 4, I found my value of K to equal 100. My value of K equaled 100. Because what I did is I did H2 times NO squared. And when you're solving for K, you're going to do rate divided by that value. Because rearrange to solve for K. Right, write it down if you have to. K is going to be rate divided by your concentrations. And then if you think about units, rate is molar per second. Concentration is molarity. Or you can just look at the overall reaction order. Overall, it's third order. Third order is m to the minus 2, s to the minus 1. Right, again, it's m to the minus 2, s to the minus 1. The seconds part of rate constant is always s to the minus 1. It's that molarity aspect that's changing because it's based on how many molarities you're multiplying against each other. All right, good. So that was kind of putting it all together, looking at writing a rate law, using that rate law to calculate the rate constant. Remember that you always have to focus on one of the reactants changing while the other one stays constant. And you just have to ask yourself, how is the rate changing based on concentration? If it doesn't change at all, as I change concentration, that's zero order. If it's exactly proportional, so if I double and rate doubles, or if I triple and rate triples, that's first order. If whatever you do to the concentration, you do that squared to the rate, that's second order. So if I double the concentration and rate quadruples, that's second order. If I triple the rate, or if I triple the concentration and I do 9 times the rate, that's second order, because 3 squared is 9. So that's looking at rate laws, rate constants, all of that. I'm going to go ahead and end this. Are there any questions on what we just looked at? You can type it in the chat if you have questions. or even what wasn't in the review, but maybe you have questions on. What would you write in the rate? So if the order is 0, you just wouldn't have that reactant in there. Because like, let's say that H2 was 0 order, you could put in brackets H2 to the 0 power, but anything to the 0 power is just the number 1. So you wouldn't even put that reactant in there. And that's why when you change the concentration, rate doesn't change, because that reactant isn't actually in the rate law at all. So solve for the rate constant. So let me go back to, let me actually look at, so this slide right here. To solve for the rate constant, you have to know the rate law. So for this one, we said that rate was K times, H2 times NO, where's my bracket? There it is, squared. Okay, so this is what we said for the rate law. So you have to have the rate law in order to calculate the rate constant. Once you have the rate law, you pick one of the trials. It doesn't matter which one you pick, because as long as you're at the same temperature, K is the same. So when we did this on the last slide of the pear deck, people could have used trial 1, trial 2, trial 3, trial 4, and gotten the same thing. And so what you're going to do is to calculate the rate constant. Keep flipping slides. To calculate the rate constant, so I'm going to pick, let's pick trial 2. I'm going to plug these values from trial 2 into the rate law. So I'll go ahead and I'll do the rate, which is 0.40 molar per second, equals K times the concentration of H2. So if I'm looking at trial 2, I'm going to put in 0.1 molar times the concentration of NO squared. So for trial 2, that was 0.2 molar. I'm just going to do this, squared. Then you're just going to solve for K. So what I did is I did 0.1 times 0.2 squared, which is 0.004. So to solve for K, I'm going to divide this over. So 0.4 divided by 0.004 is 100. So once you have the rate law, you're just using information from one of the trials. You could do trial 1 instead. You're still going to get 100. And then it just comes to looking at units. So m times m squared is m cubed. So when I divide that number over with m cubed, one of the molarities cancels. So that's how we get 1 over m squared times s, which is m to the minus 2, s to the minus 1. Yep. Any other questions? So, and I can answer other questions right before, but I'll just go over the quiz. So again, for this quiz, you can use your notes and a calculator. You can also have your periodic table and equation sheet out. You probably won't need it, but if it helps to have it out. But you can use your notes and a calculator. You also need the zip grade information that I sent to you yesterday via email. So I emailed everyone a sheet that looks like this, and it said student instructions to access the student portal. If you have Mr. Carlisle, you've done this before. You cannot use the same information as his class, which is why I emailed everyone this separately yesterday. So if you haven't checked, make sure to check your school email. We will also be using this in the future, so just save this information somewhere, put it in your AP Chem folder or something. You have 35 minutes for this quiz. The quiz will auto-submit after 40 minutes. So if you're not done after 40 minutes, it will auto-submit. So I'm going to give you time updates, so just make sure that you're listening to the time updates. People in first period, I think one person went up until the 40th minute. Make sure that you just flip your camera on during the quiz. And then after the quiz, you can open the Beers Law simulation. You can start working on that assignment. Once you are done with the quiz, you can leave the Google Meet. So you can work on the Beers Law simulation on your own. You can leave the Google Meet. But if you cannot find the zip grade information in your email, send me a remind message and I can send you your zip grade info. Don't put it in the chat because then everybody can see it. So you can send me a remind and I can send you your information. But I emailed it to everyone yesterday. If you took the Unit 4 test online, it's the same information that I sent you for the test. I sent you guys a separate email yesterday. So if you go into Google Classroom, the quiz has popped up. So it says quiz, Kinetics quiz number 1. When you click on that, it gives you all of the information. And then there are 2 bonus questions as well. And I've actually just put the bonus info in the assignment as well. Has nothing to do with chemistry. So hopefully everyone gets the 2 bonus points, but it has the link for the student portal. So once you have your information for the quiz for zip grade, you can go ahead, just flip your camera on. You can use your notes, right? Calculator, but then you have 40 minutes for the quiz. So really by the end of class is the biggest thing. Right? And if you need that zip grade info, just send me a